Okay, for homework 10-1, unfortunately some of you have to do this. Hopefully you're doing this on Sunday night. I'd like you to try to do these graphs and all this work best you can. Listen to any keywords if I have them. This will give you full credit for homework 10-1, give you practice. Alright, so for these, they want the equation of the line first, slope-intercept form, where over 1 up 2 put together as slope 2 over 1, and my y-intercept of 1 gives me this equation as 2x minus 1. Minus 1 is the y-intercept on the y-axis. Over 1 up 2 is my slope of that line. These, they want you to solve algebraically to rearrange and solve for y and see which one matches. On test day, like this one, as soon as you get the answer, I would maybe check 1 or 2, but then keep going. So right here, add 10x, bring down 5y, 10x minus 5, adding that 10x first, those go away, and then divide both sides by 5, and that will cancel those 5's away and give me that first equation, y equals 2x minus 1. So I can clearly see that that matches. I'm kind of okay with that. I'm going to try my others just to see. So I'm going to add 8x over here, bring down the 4y, equals 8x plus 4, divide both sides by 4, split and divide everything over there by 4, and that'll end up giving you 2x plus 1. Not good. Last one. Plus 10x gives me 5y equals 10x plus 5. And when I divide that by 5, it gives me that 2x plus 1, which again is not true. Close. Alligator. Alright, next problem here. They want you to solve these for y and graph them. So x minus y more than greater than 2. Other equation is 2x plus 3y less than or equal to 6. So I'm going to take away x right here, minus 1x, bring down the negative y, bring down my inequality, greater than negative x plus 2, divide everything by negative 1, which flips my inequality and makes this y less than 1x, positive 1x, minus 2. That's going to be my line in red that I graph. Buffalo. The next problem, solving this for y. Take away 2x on both sides, bring that down, divide both sides by 3. And that gives me y less than or equal to negative 2/3 x plus 2. This one's going to be a dotted line shade below. This is going to be a solid line shade below. So here we go. Negative 2 on my y-axis. 1 over 1 is my slope. Over 1 up 1, over 1 up 1. Stair step the opposite way. That is a dotted line through those points because my inequality is missing the line underneath. So dotted line, make sure you see that to get full credit. Shading below puts all those coordinate points that are a solution to that inequality. All of these points under here. All those shaded area, all those points can satisfy that inequality. The blue one, start at 2. Go right 3 down 2, right 3 down 2, stair step the other way. That is a solid line because of my inequality. Less than, also shading below, less than shade below. If this would have been more than, shade on top. Less than shade below. If this would have been more than, I would have shaded on top. Less than below, more than on top. Both these are below the lines that are drawn. The 1/4 of the graph where those shaded zones intersect is this one part of the graph right here. Fill that in. All of these coordinates will satisfy both inequalities. All right, let's keep going. Whale. Whale. Okay, this one. They want you to write the inequalities and match it. This one is y. Because my inequality has a dotted line, it's going to be plain inequality without the equal line. Because this is shading above this red line, it's going to be more than. So just because looking at that, I know this is more than. Not less than, not shading below, not more than or equal to because it's dotted. Y is more than. This slope, right 3, up 1 put together, right 3, up 1 gives me a slope of 1 over 3 x minus this 1. That is that equation. So you can see that first one matches automatic. This is close, but not quite. The blue one, y, less than or equal to. I can see it's less than or equal to because the line is solid and because I'm shading underneath that blue line. That's why it's less than. More than would have been like this, but this is less than, solid line equal to. The slope of this line from here, going right 1 down 3, connecting two solid points, is a slope of -3 over 1 or -3x plus 1. So you could see the only choices are these first two. The next ones are close, but because of the slight errors, those are not good. This is close, but that's not the right direction. This is close, but it doesn't have the equal line under it. This is close, but it's in the right direction, but an equal line shouldn't be there. And this one is the wrong way and missing the line. Okay, this word problem, be able to write a system of inequality word problem, knowing that whenever you see the word at least, that's more than or equal to. When you see no more than, that's at most. Less than or equal to. You got to know that just by the wording. I'm going to use S as shirts, H as hats. I'm going to do this first situation right here. I want to buy at least shirts and hats. Total number of shirts and hats, adding them together, is at least more than or equal to 80. That's my first equation. The number of shirts and hats added up total is at least 80. 80 or more. 81, 82, 100. I could spend no more than 300, at most 300, using my cost. $19 now for every shirt, plus $13 for every hat, is at most less than or equal to 300. And again, that's all you have to do is write those inequalities. Nordhoff. All right, almost done. This problem, all they want you to do is not be intimidated by all these words and functions, but just give me the coordinate where these two intersect. And you can see that coordinate is clearly 2 for x, 1 for y. Don't mix that up. Over 2 for x, up 1 for y. And then the last one. This one, they want you to see which of these is equivalent. And these, of course, you're going to distribute this 3 and then combine the two like numbers to get this. If you remember, this is the equation using dx plus f of 0 or mx plus b, or the slope and the y-intercept, or the d term and the 0 term. That's what that is. This is trying to show it in a way where we're timesing d times x minus 1 and using the first term instead. Remember, they give you the same answer because they're equivalent. So this first one here, 5, leave that 5 alone, distribute the 3. 3 times x, 3 times -1. That gives me 5 still, equal 5 plus 3x minus 3. The 5 and the 3 combine to give me negative 2, so that gives me 3x plus 2, which is not the same. The next one, 1 plus 3 times x, 3 times negative 1 gives me 1 still, plus 3x minus 3. Combine the 1 and negative 3 to give me 3x minus 2. And again, almost, but not quite the right answer. Don't say, oh, that's the same. Nope, those are not the same. No, don't do that. The last one, times this 4 times x, 4 times negative 1 gives me 6 still, the 6 stays, plus 4x minus 4, and that one gives me 4x minus 2. I could see none of these worked. If I wanted one that would have been equivalent, it would have had to look just like this I'm about to show you. It would have had to been f of x equal to 7 right there, plus 3 times x minus 1. That's the same because 3 times x, 3 times negative 1 gives me 7 plus 3x minus 3. 7 and the 3 combine to give me 4. F of x equals 3x plus 4. Those are equivalent. To prove to me that you're listening, I'd like you to write this as a sequence of numbers. 0 term is 4. This first term is 3 more than that, 7. There it is. This third term is 3 more than that, 10. To prove to me that you're listening, I would like to see the sequence of numbers that matches these. The explicit form using the 0 term and this explicit form using the first term. So again, the 0 term, 0 for x, would be 0, 4, and then 1, 7, and then 2, 10, and then 3, 13. Show that, and you will get full credit. Good luck.